Hello, friends. Welcome to my channel, Academic Made Easy Peasy. If you have not subscribed my channel, subscribe it and also click the bell icon.
Now we are going to see the addition of vectors. So in addition of vector we have two types. One is triangle law and next one is parallelogram law of vector addition. So first let us see triangle law and then let's see parallelogram law of vector addition. So now first one is triangle law of vector addition. You all might think, what is this triangle law of vector addition? So what is a triangle? That has three sides, right? So when there is two vectors, we will be having the third vector which will be equal to the sum of those two vectors. That is what the triangle law of vectors. So first let me just read you the definition and then let us move on for the further procedures. If two vectors are taken along two sides of a triangle taken in order, then their resultant is represented by the third side taken in opposite direction n. Okay, so now I have given you an example ABC. This is a triangle ABC there. So now I have drawn the vectors. I have already taught you where does the vector start and where does it end. So if there is an arrow mark, the vector is represented in the direction with an arrow mark. So I have drawn AB vector in this direction, that is right from the left side to right side. And I have drawn one more vector, that is B to C. Okay, that also I have represented with an arrow mark, and A to C I have drawn, and this is in the opposite direction. So now what they are saying in the definition is that if there is one vector, say AB, let me draw it again for you all. So A, B. Okay, so this is the first side of the vector and the second side. Okay, so let this point be B, C, sorry, C. So this vector is in this form. Okay, so now I'm just going to join these 2 points. Okay, if I join these 2 points, I will be getting one more side. So that side I will be drawing the vector in the direction opposite to it. So this one is a resultant vector, that is C. I'm drawing a vector from A to B. Okay, then from B to C. Okay, so if I want to add AB vector, AB vector plus BC vector, and what will be my resultant vector? I don't know, right? So only they are saying that this third side will be the resultant vector. So let this vector be R vector or AC vector. So therefore we say that AB vector plus BC vector equals what? AC vector. Okay, I think this will be clear. Two vectors will be in the same direction. The third vector will be in the opposite direction. This is what the triangle law of vector addition. So now let us see the parallelogram law of vector addition. So now parallelogram law of vector. If two vectors are represented along the adjacent sides of a parallelogram vector, then their resultant vector is represented by the diagonal of the parallelogram, which is coinitial with the given vector. So what they are saying is that there are two vectors which is passing, okay, with a same point that I have taught you that it has coinitial vectors, right? The two vectors which has the same initial point is called the coinitial vector. So the coinitial point is O. Okay, so the two vectors is drawn from O to A and O to B. This is forming a parallelogram. Okay, so in the previous vector addition we saw that there was two sides of vectors and these two sides can be joined. So we joined and said that it is in the opposite direction and the resultant vector is found. But if we just take this one, OA and OB, so it has same initial point, but does it has any endpoint where we can join those two vectors? No, right? So that is what they are saying, that take the imaginary vector. vector. So already I have taught you that the parallelogram vectors are equal. So only in the parallelogram, the opposite sides will be equal. So only I have taken it as OA vector and BC vector is equal. OA vector equals BC vector. Okay, similarly, OB vector equals AC vector. OB vector equals AC vectors. If you just see, if I draw a diagonal for this parallelogram, you will find that two triangles are formed, right? So taking these two sides, see, this vector is going this way and this vector is going this way. So we have already learned this in triangle law of vector, right? So therefore I join these 2 points and say that this is my resultant vector R, and I say that these two are, the sum of these two are R vector. So that is OA vector plus AC vector will give me this resultant vector, which is a diagonal for this parallelogram. Okay, so that's what I have written. OA plus OB equals OC vector. Why I am saying OB vector here? Because AC is equal to OB, right? So I'm just substituting the value of AC here. That is OB. Next, see, see, I have written here OA vector plus AC vector equal to OC, or else you can just say it as OB vector plus BC vector equals OC vector. Like that also you can say. Here I have named it as R vector, right? So here also you can add as R vector. I think you will be clear with parallelogram law of vector and triangle law of vector addition. Now we are going to see the properties of vector addition. We saw what is vector addition into laws of vector addition, right? So now we are going to see the properties of vector addition. So just know these properties. While we do the sums, I will just explain you more clearly. So just know what is what in this video. So vector addition, consider any two vectors, say A vector and B vector. So we all know that addition is commutative, associative, distributive, right? So the same way vector addition is also commutative, associative, addition identity, and additive inverse. Commutative law means what? A vector plus B vector equals B vector plus A vector, right? Next one, associative law. So A vector plus B vector plus C vector equals A vector plus B vector plus C vector. Next, addition identity. What is addition identity? Adding some number with 0, right? That is what addition identity. So A vector plus 0 vector equals 0 vector plus A vector equals A vector. So you can just write it as 0 or 0 vector. It is always preferable to write 0 vector because we are dealing with vectors. Okay, then additive inverse. Additive inverse means what? If we have a positive number, we will be adding with negative number. If we have negative number, we will be adding with positive number. That is what inverse. So additive inverse. So A vector plus minus of A vector equals minus of A vector plus A vector gives us 0 vector. As we do numbers, the same way will be followed here, but only the vector quantities will be added. Okay. Still now we were seeing about addition of vectors. So now we are going to see multiplication of vectors. So especially multiplication of vector by scalar. So you know what is vector, and I'm sure that you know scalar, but still let me explain what is scalar. So what is vector? Which has both magnitude and direction, right? So now, what is scalar? So scalar is nothing but which has some value, that's it. For example, magnitude, which has no direction. Okay, let A vector be a given vector and lambda be a scalar. Then the product of vector A by the scalar lambda, denoted lambda A vector, is called the multiplication of a vector A by a scalar lambda. Okay, so this is nothing but we are multiplying a vector with a scalar quantity or any number, any constant. Okay, so this scalar is always a constant. It can be both positive and negative, which I have mentioned here. So we have a vector and we are multiplying by scalar, means it is just lambda a vector, that's it. Okay, so lambda a vector. So now magnitude of lambda a vector will be mod. I said no, we will be denoting with a mod symbol, that is mod of lambda a vector equals mod of lambda into mod of a vector. Both are also same only. So even if lambda is negative, when we take the magnitude, we get a positive scalar quantity. Okay, and one more important note is that if lambda is 1 by the magnitude of a vector, then lambda a vector equals, we write it in such a way, right? So what is mod of lambda? I mean lambda, it is 1 by mod of a vector. So mod of lambda is same as 1 by a vector mod, right? So therefore I've written mod of a vector divided by mod of a vector, which is 1. As we do for normal multiplication, addition only we will be doing here also. The only difference is we will be using a vector quantity, that's it. Now I'm going to teach you a very important topic, that is unit vector. As I said you in the previous video, the unit vector is very important. Okay, so as we finish off with the components of the vector, I will teach you how to calculate this unit vector. Okay, just know the formula here. So unit vector is denoted by a cap on top. We say this as cap. So a cap equals 1 by mod of a vector into a vector. Okay, so unit vector is represented with a letter on top of it. We have a cap. So that is unit vector of a. We will be reading this as unit vector of a. So unit vector of a equals 1 by mod of a vector into a vector. Okay, so this is not mod, this is actually a vector, and this is the magnitude of a vector. Okay, so now next let's move on to the next topic, components of a vector. So components of a vector means what are the components of vector, what a vector equation contains, that is what the components of vector. So I'm just saying, let r vector equals xi cap plus yj cap plus zk cap. So see, a letter with a k on top, what does it called as? It is a unit vector. Okay, so these are the unit vectors, and x, y, z are some it might be some variables or any constants. It depends on the equation. Okay, so this is called the equation. This equation has a special name called component form. Component form. Okay, so if a vector equation is represented in such a way, this is called a component form. Vector equation or any vector that has I cap plus yj cap plus zk cap, it is called a component form. And I cap, j cap, k cap, these are called vector components. Vector components. Okay, these are called vector components, and x, y, z are called rectangular components. Rectangular components or scalar components. Scalar components. So these are the things that you have to know. So this entire thing is called the component form, and I cap, j cap, k cap is called vector components, and x, y, z are called rectangular components or scalar components. Okay, so how to calculate the magnitude of our vector? Magnitude is nothing but mod of r, right? So mod of r will be calculated as x square plus y square plus z square. Okay, so see, this is what the vector equation. So from this equation only we will be calculating the magnitude of it. So square root of x square plus y square plus z square. That this is what the magnitude. Hope you will be understanding what is magnitude and how to calculate the magnitude. Okay, I think hope this is clear. So this topic is over. As I said you that I will be teaching you how to calculate unit vector. I will be doing it now, so listen carefully. So here I said this as a cap, right? So now let me find the unit vector for this one. Okay, so let me have it as r cap. Okay, so r cap equals, as I said, 1 by mod of this, no? So 1 by mod of r vector will be root of x square plus y square plus z square. Okay, so next what I have, vector a. So vector r vector fully I can just write here. So xi cap plus yj cap plus zk cap. This is how I find my unit vector. Okay. Now I'm just gonna say you some important result in the component form. Okay, so as I said, vector addition, right? So now we are gonna see the vector addition. So let us have two vectors, say a vector and b vector. Let me write this as a1 I cap plus a2 j cap plus a3 k cap. B vector be b1 I cap plus b2 I cap and b3 k cap. So how am I going to add? So now we will be just taking the DRs to add the addition. DRs is nothing but direction ratios. So we will be just adding direction ratios. We will not be adding this vector components. Okay, so a vector plus b vector, how will I write is that I will be just adding the straight ones. A vector plus, sorry, a1 plus b1. Okay, then a2 plus b2 j cap, a3 plus b3 k cap, as we do for algebra, right? So say we have 2x plus 3y plus 4z equals something. Okay, so next we have 4x plus 6y plus 8z is equal to something. How will we do it? We will be adding these two, that is 4 plus 2 will give us 6x and plus 9y plus 12z, right? So we will be doing it in this form. So therefore, even for vector addition, we will be doing it in such a way. So see here, a1 plus b1 I vector, a2 plus b2 j vector, a3 plus b3 k vector. Hope this will give you a clear idea. And even for vector subtraction, we will be doing the same. A vector minus b vector equals a1 minus b1 I cap, a2 minus b2. See, a2 minus b2 j cap, a3 minus b3 k cap. If it is b vector minus a vector, we will be getting it as b1 minus a1 I vector, b2 minus a2 j vector and b3 minus a3 k vector. We will be doing it in such a way. If you have any doubts regarding this part, comment in the comment box so that I will make one more video to make your doubts clear. So for more and more videos, I would like you to give a thumbs up and also subscribe my channel to get more videos. Now, I'm saying that a vector and b vector are equal. Then what should it be? So what if I say 2x plus 3y plus 4z equals 2x plus 3y plus 4z? Yes, so I have to check, right? Is 2x and 2x equal? Yeah, it's right. 3y equals 3y. Is it equal? Yeah, right. 4z equals 4z. Yeah, right. No? So then I will say that these two equations are equal. So the same way, what I will be doing, if a1 equals b1, then it is equal. a2 equal to b2, a3 equal to b3. If all these three conditions get satisfied, then I say that my vector a equals vector b. Next, I've already taught you this in multiplication of a vector by scalar, right? So I just thought your gist of how to write multiplication of a scalar by vector will be written as scalar into that vector, given vector, right? So how will it be carried on with an equation we are going to see. So lambda into a vector means lambda into a1 I cap. With each and every term I will be multiplying. So lambda a vector equals lambda a1 I cap plus lambda a2 j cap plus lambda a3 k cap. Okay, so now this is also a very important formula that you will be doing it in analytical geometry in the next chapter, that is 3D geometry. So this is also very important. So if b1 by a1 equals b2 by a2 equals b3 by a3, that is direction ratios. No, I'm just taking it as proportion. If these three are proportion or it is equal to any constant, then it is said that it is either parallel or collinear. Okay, they are either collinear or they are parallel. Okay, so this is a very important formula, so just keep this in mind. Next, if L, M, N are DCs of a vector, then Li cap plus Mj cap plus Nk cap equals cos alpha I cap plus cos beta j cap plus cos gamma k cap. It's the unit vector in the direction of that vector. Okay, we're going to learn the properties of multiplication of a vector by a scalar. Okay, now consider two vectors, a vector and b vector. Okay, and scale, as I said, scalars can be any constant, that I'm taking it as k and m. So what if I just add a scalar to vector and some other scalar with the same vector? Okay, so so now just consider 4x plus 3x equals 7. Okay, so what will I do? 4 plus 3 into x equals 7, I write, right? So the same way I'm just writing it for vector also. So k a vector plus m a vector. Okay, so k plus m into a vector, I can write it. So now for this also, as we do for algebra, the same thing is followed here. So k into a vector plus b vector can be written as k a vector plus kb vector. Okay, and this also the same, k into m a vector equals k into m into a vector. That's it. Okay, the two vectors a and b are collinear if and only if a vector equals lambda b vector or lambda a vector equals b vector. As I said you in the previous slide, the same thing. Okay, so now we are going to learn vector joining 2 points. So we are just considering 2 points P1 and P2. So if P1 x1 comma y1 comma z1 and P2 x2 comma y2 comma z2 are any 2 points in the plane, then the vector joining P1 and P2 is, so 2 points will be given. Okay, so they're saying that x1 comma y1 comma z1 and x2 comma y2 comma z2. Okay, so they're saying that this vector is joining these 2 points. Then how to just calculate? Okay, so we should have one vector, right? So how to calculate the vector joining these 2 points? So as we do it for coordinate geometry, right? So last year we would have learned it. So we will be just taking this point first and subtracting this point next. So that's what I've written. So OP, I've just considered this one. So OP vector minus OP1 vector, or see, I'm just considering a point center, that is O, and I'm saying that OP vector and PO vector. So I'm just writing it as OP vector because it is in the opposite direction. No, so as I said you in the introduction video, if P1O vector should be written as OP1, then what I said, you have to add a negative symbol in the front. So we will get OP1 vector. So minus OP1 vector, that's what is given here. So what we will be doing is that x2 minus x1, so x2 I cap plus y2 j cap plus z k cap minus x1 I cap plus y1 j cap plus z1 k cap. So we will be just subtracting this. So you know the properties of vectors, fraction, addition, right? So the same thing you will be doing it here. Okay, so now I'm just going to teach you section formula. The section formula is very familiar to us right from our 10th standard. So even here we will be following for some of the sums here. So just keep this in mind. Let A and B be 2 points with position vectors A vector and B vector respectively, and P be any point which divides AB. Okay, they are saying like a vector AB, and they're saying P vector divides here or internally or externally. Okay, so if it if the point P divides internally, then what is the ratio? So m B vector plus n A vector. So let us have this as n, and let this be B vector and A vector. Okay, at this point let this be A vector and B vector. So we will be just crossing this here, m B vector n A vector plus, okay, divided by m n. Okay, similarly, if it divides externally, then we have to subtract. So mb vector minus na vector divided by m minus n. And if it is a midpoint, we will be saying that a vector plus b vector divided by 2. That's it.
If you have any doubts, mention it in the comment box.